Hello. So my name is Akshaj Jois, and I've been a serial entrepreneur for the last couple of years. And with the team I've assembled over the last year, we've created a food tech startup called Jois Food Technologies. So our team includes two food scientists who've been involved at Nestle, Unilever, American Whole Foods for the last 20 years. Andrew, who's kind of been in strategic operations and business operations and Whole Foods market, has kind of gotten that background knowledge in financials, business, and also in the culinary side. While Rick has been developing, been a process authority and food technician, and has that nutrition R&D background. And finally, our fourth founder, Joachim Muller, who's a postdoc fellow from Harvard, has been developing 3D printing systems for the last 5 years. And many of these novel technologies we are adopting into the food space, as there is a white space and opportunity in the alternative meat sector, and we are converging the industries of 3D printing and food technology together. So our company is Jois Food Technologies, the future of food. So what we're offering, our solution is 3D food printing technology as the next advanced co-manufacturing and food production platform for sustainable foods. So unparalleled innovations that our technology includes is the personalization of taste and texture, plus the unlimited food design from ingredient usage and capabilities to shape and geometry design. Secondly, the breakthrough fabrication speed allowed by some of the novel technologies I'll cover in the next couple of slides that were a breakthrough in Joe Chen's research. Finally, the scalability and cost, since many of these 3D printing systems have been optimized for the couple of last 4 to 5 years. And now we're adapting it into the food space. And cost, we are working with R&D partners and food partners and getting finished ingredients rather than building ingredients 0 to 1. And finally, transparency. You'll know exactly the food ingredients that are going into the machine and that are being printed in real time. So now I'll cover some of the proof of concept plus research validation of the 3D printer systems and printing capabilities in the lab. So in these couple of pictures, you can see texture creation plus fiber alignment through the 3D printing system, which allows for this nice microstructure. And whenever you're building larger food structures such as steak and pork ribs, you don't experience collapse because of the rigid cell walls and cell alignment. Here you can see ink customization of the different food ingredients, which allows you to make different types of food inks. So here you can see amino acids and binding agents embedded within jackfruit oleogels, all embedded within texturizers, growth factors, and proteins. So what this shows is that there's almost unlimited food design capabilities to get your meat paste or cell and plant-based bioink. And then finally here, you see rapid material switching of the different food materials, and which can increase print speed, and take the less time needed to build the food structure. So here you can see 10 hertz per second, and finally here is 50 hertz, which is basically switching between 50 switches per second. So, and then another slide here is just more printing demonstrations. So this is food printing of gelatin hydrogel bioink. And then here you see the layer by layer approach of different size printing systems. So here's your 1 nozzle, 4 nozzle, and then 2D multi-nozzle array. And the relationship shown here is the more number of nozzles and print heads you add, the more that is extruded and less time needed. And so different structures can be built. So we're taking some of this research and kind of validation and bringing multi-layered voxel sustainable food printing. So here's like a 4-ounce pork belly, and with a 256 nozzle printer set to a print speed of 10 millimeter cube per second, the food would be printed within 1 minute. So here's an example of a machinery setup. And the market value we're capturing is within the food industry, the pork industry, food service, alt meat industry, and the smart kitchen industry. So our commercial strategy is two-phased. One is becoming an advanced co-manufacturer and working with alt meat partners, and the other is going into the restaurant groups and food and having our 3D printers in site at restaurants. And then finally, what we're looking for is mentorship and funding to specialized 3D alt meat printers and getting ready to scale, which includes assembly of printers and lab space, optimizing and engineering modifications, and finally, testing rheology and different combination of food products to get our pork belly prototype. Yep.